Hi, hello, good evening everyone. I hope I am perfectly audible and visible to each and everyone present over here to watch this particular session. Okay, in this particular session we are going to discuss about the chapter Classification of Elements in Periodicity and Properties. That is the second part. You can see over here, this is the major point we have covered in the last class. That is from here, that is the genesis of periodic classification to long form of periodic table that we have already covered in our first session, right? In this particular session, we are going to discuss these two topics that are nomenclature of elements and classification of elements, right? Okay, without wasting any time, we can just directly move to the topic, that is the IUPAC nomenclature of elements, right? We have to find out the IUPAC nomenclature of the elements having atomic number greater than 100, right? There will be simple points you have to be noted, that is, there should be some root names for each digit present in the atomic number. First, you have to put together all the root numbers, right? All the root names together that corresponds to digits from 0 to 9, which make the atomic number. Then, you have to add IUM at the end in order to get the complete IUPAC name of that particular element. And also, in order to find out the symbol of the particular element, there will be 3 letters corresponds to each digit, right? These are the 3 points you have to be noted to write down the IUPAC nomenclature of the particular element having atomic number greater than 100, right? Clear? Now let us see some examples. Before that, we have to find out the digits and corresponding root names. Let's see here the first digits, right? For 0, the name corresponds to nil having an abbreviation of N. Similarly, for digit 1, it is the name having un having the abbreviation of U. Similarly, for digit 2, it is bi having the abbreviation of B. For 3, it is tri having the abbreviation of T. And 4, it is quad having Q. 5, it is pen having P. 6, it is hex having H. 7, it is set having S. And also there will be 2 more numbers, right? 8, it will correspond to the name oct having an abbreviation of O. And the last digit, that is 9, having the name of N, E-double-N, with an abbreviation of E. This is very important. In order to write down the IUPAC nomenclature of the compound or the element, these digits should be known, right? Now let us see the example. Okay, if I am giving a particular atomic number here, that is Z is equal to 105, what do you have to do? Hi Niku, hi, good evening. Okay, if you are giving an atomic number of 105, what are the steps you have to do first? First, you have to identify the digits, right? Let's see here. These are the 3 digits here, 1, 0 and 5. Then you have to find out the root name for the particular 3 digits, right? For 1, it is un. For 0, it is nil. And for 5, it is pen, right? We got the root names. Then we have to put together all the 3 roots, right? I am writing here un, nil, pen, and adding IUM at the end, right? This will be the IUPAC nomenclature of this particular element having atomic number 105, right? Clear? Is the thing clear? Just let me know. Okay, then we have to find out the symbol also, right? As I already mentioned that in the case of a symbol of an element, there will be 3 letters, right? So, for this particular element, I am taking the first 3 letters, right? U, N, P. The thing should be mentioned that the first letter should be capitalized. It should be in capital. Clear? Hi Ashik, good evening. Is the thing clear? Kamil, okay, let me try. Is the thing clear now? Okay, now I am giving the next atomic number. You should predict what will be their IUPAC nomenclature as well as the symbol. Give me the answer. The atomic number is 108. First you have to find out their corresponding digits as well as their root names, right? What will be the root name here? For 1, what will be the root name? Hi Loria, my name is Surya. Okay, what is the answer here? Yes, UN. Let me try. 1 stands for UN, 0 stands for nil, then 8 stands for octs, right? Which means nil octium, right? UNO. This will be the symbol as well as IUPAC name for the particular element, right? Clear? Yes, Anya, you are right. Kapil, you are also right. Great. Okay, I hope that point was clear for everyone. Now let me move to the IUPAC nomenclature of all the heavy elements. You can see a table here starting from 101 to 118. These are the name according to the IUPAC nomenclature. You can see over here their symbol also. And nowadays these elements are discovered and particular name are given for these particular elements, right? Along with their symbols. You can see over here. Clear? You must have an idea about this table. Sometimes in an exam point of view also, they will give the IUPAC official name to find out their IUPAC nomenclature. Just like give the symbol like this. Clear? Is that clear now? Now let me move to the next topic, that is the classification of elements in the long form of periodic table. As you can see over here, this is our long form of periodic table, otherwise again called as a modern periodic table, right? Here you can see that, as I already mentioned in your previous classes, all the elements are classified into how many vertical columns? Anyone? How many vertical columns? All these elements are classified into 18 vertical columns, right? Called as groups. Similarly, 7 horizontal rows, right? 7 horizontal rows, right? Periods. As you can see over here that these elements are arranged according to their increasing order of atomic number, or it can be arranged based on their electronic configuration, right? When we move very closely into the periodic table, very deep into the periodic table, we can see that there will be different periods, right? If you consider the first period here, how many elements are present here in the first period? How many elements are present over here in the first period? Two, right? Including hydrogen and helium, 2 elements are present over here in the first period. Now let me move to the next period, that is second period. It starts from lithium, right? Lithium to neon, including 8 elements. Clear? 8 elements are present over here in the second period, starting from lithium to ends with neon. Then let me move to the third period, that is starting from sodium to ends with argon, having again 8 elements, right? Again 8 elements. Now let me move to the fourth period. It will start from potassium to ends with krypton, right? How many elements are present over here in the fourth period? How many elements are present over here in the fourth period? Just count. 8, 18 or 32. Right? 18 elements are present over here in the case of fourth period. Similarly, in the case of fifth period also, starting from rubidium to xenon, again it have 18 elements, right? Right? Now I am directly moved to the sixth period. It starts from cesium and it ends with radon, right? It ends with radon. How many elements are present over in the case of sixth period? Kabil, 36. Are you sure? 36 elements are present here. Okay, let us check. In the case of sixth period, right? These are the elements starting from cesium to radon. Here you can see that after lanthanum, 14 elements are present over here in the same period, right? In the sixth period. These are the 14 elements present over here. Including these 14 elements and these elements, you will get 32 elements in the sixth period, right? 32 elements in the sixth period. Clear? Similarly, in the case of seventh period also, you can see that while calculating these 14 elements also, you can get that. Similarly, 32 elements, right? 32 elements are present over here in the presence of seventh period also. Which means that these sixth period contain the actinoids as well as sixth period contain lanthanides. Similarly, seventh period contains actinides to form 32 elements each in each of the period, right? Now, from these periods, you can say that which one is the shortest period? Okay, Renu Singh, which I want to repeat? This complete periods element or the last point only? Okay, which one is the shortest period here? Which one is the shortest period here among these 7 periods? Any guess? Okay, the second period is the shortest period having only 2 elements, right? And also you can see that the sixth period will be the longest period among these 7, right? Sometimes you have the doubt that why 7th period is not the longest period. There is a reason behind that. In the case of 7th period, some of the elements does not follow all the properties like electronic configuration and all other chemical as well as physical properties. So that we can say that the 6th period containing 32 elements are the longest period among these 7 periods. Right? Clear? Is the things clear? Yes. Okay, the same points are written in the slide also. You can see that the first period has 2 elements, right? 2 elements which are the hydrogen and helium, right? hydrogen and helium. The hydrogen has the electronic configuration of 1s1 and helium has the electronic configuration of 1s2, right? Therefore, this will be the shortest period among the 7 periods. Then again, when we move to the second period, it starts with lithium and ends with neon. Already the electronic configuration also mentioned here. You can see that 8 elements are present over here, right? Then when we move to the third period also, it contains 8 elements. 8 elements. And for the fourth period, it contains 18 elements, right? 18 elements. And there will be a point you have to be noted that in the case of chromium and copper, right? There will be 1 electron in the outer shell. As you can see in the next slide also in detail, right? Clear? Then when we move to the fifth period, right? It starts with rubidium and ends with xenon having 18 elements again. How many elements? 18 elements again present over here. Now let me move to the sixth period. Starts with cesium and ends with lutetium, giving the 4f series, that is lanthanide series. It also contains 32 elements in the sixth period, making them the longest period. Right? Then the last period, that is the seventh period, again contains 32 elements, in which the last electrons are entered into the 5f orbitals, right? Including the actinide series. Clear? Okay, now let me move to the electronic configuration in the groups. Right, as you can see over in the periodic table, these are the groups, right? Starting from 1 to 18. If you am taking here, in the case of first group, what are the elements present over here? Including hydrogen, lithium, sodium, potassium, rubidium, cesium and francium, right? While checking the electronic configuration of these elements, you can see that the general electronic configuration is ns1, right? For example, here for lithium, it is 2s1. For the next element, sodium, it is 3s1. For potassium, it is 4s1 and so on, right? Which means ns1 is the general electronic configuration of the first element, first group element, right? ns1 will be the general electronic configuration of the first group element, right? Similarly, what will be the electronic configuration of second group element? Any guess? Just look into the periodic table and give me the answer. What will be the general electronic configuration of second group elements? Let us see here for beryllium it is 2s2, for magnesium it is 3s2, for calcium it is 4s2 and so on, right? Which means ns2 will be the general electronic configuration of second group elements, right? Now let me move to the group 13 to 18 group elements, right? Here this is the 13th group and this is the 14th group, this is the 15th group, this is the 16th group, 17th and this is the 18th group, right? While observing these electronic configuration, you can see that here the general electronic configuration of 3A or group 13. It is NS2NP1, right? Then for group 14, it will be NS2NP2. Similarly, for group 15, NS2NP3. For group 16, NS2NP4 and group 17, NS2NP5 and so on, right? This will be the general electronic configuration of group 13 to 17 group elements. Then, what will be the electronic configuration of group 18 elements? That is our noble gases. For example, if I am taking here krypton, the general electronic configuration is 4s2 4p6, right? Because it is belong to the fourth period, we can say that the electronic configuration, general electronic configuration of group 18 elements is NS2NP6, right? NS2NP6. Is that clear? Just let me know Is the things are clear for you? Now we are moving to the next classification, that is the classification of elements into blocks, right? You must have an idea about the blocks of elements, right? We have classified the whole elements into 4 blocks according to their last electrons enters into which subshell, right? The electron enters into which subshell. So that we have divided all the elements into 4 blocks, just like that: S block, P block, D block and F block elements, right? Hi Vidya, good evening. Again, this is our periodic table. You can see that these 2 group elements, right? This is our first group and this is our second group. While calculating or while seeing the electronic configuration of these elements, you can see that the last electron always enter into the S subshell of these 2 group elements, right? Including 1 and 2. Therefore, these elements are commonly known as S block elements. S block elements. Right? Now, let me move to the P block elements starting from group 13 to 18. As you can see that here also the last electron always enter into the P subshell or P orbital of the each element, right? In the case of group 13, group 14, 15, 16, 17 as well as in 18 also, you can see that the last electron is always entered into the P subshell, therefore it is known as P block elements. P block elements, right? Now there will be a small classification, right, in between S and P block elements. What are they? From group 3 to 12, from here to here, right? The last electron is always enter into the D orbital or D subshell of the element, right? Therefore, these elements are known as D block elements. These elements are known as D block elements. Then what is left over here? Which block is left over here? F block elements, right? As you can see over here, after lanthanum, this is the lanthanum element present over here. After lanthanum, you can see that. Okay, this is after lanthanum, from cerium to lutetium, you can see that the last electron always enter into the F orbital, right? That is the 4F orbital. Similarly, in the case of these elements, from thorium to lawrencium, you can see that the last electron is always entered into the 5F orbital. So that these elements are known as F block elements. F block elements. These are the whole classification of the whole elements into different blocks as S block, P block, D block and F block. In between these S and P block, you can see that D block elements, this is the transition from highly electropositive metals to highly electronegative non-metals such as, therefore these D block elements are also known as transition elements. Okay, is the things clear? Okay, now let us take the each and every block elements in detail. First one is the F block elements. As I already mentioned that in these elements, the differentiating electron or the last electron always enter into the s orbital, right? In the s orbital, therefore this is known as the s block elements, right? And also you can say that in the case of s block elements, you can see that two group elements, right? Group 1 as well as group 2 elements correspond to the s block elements. These group 1 are known as alkali metals. Alkali metals. And the group 2 elements are commonly known as alkaline earth metals. Alkaline earth metals. These group 1 and 2, that is the alkali as well as alkaline earth metals, constitute the s block elements, right? Now, while counting or observing the electronic configuration of these elements, you can see that the general electronic configuration of these s block elements is ns1 to 2. For example, if I am taking here lithium, what will be the atomic number of lithium? What will be the atomic number of lithium, or what will be the electronic configuration of lithium? One s two, 2s1, right? 1s2, 2s1. If I am taking the beryllium here, 4, right? 1s2, 2s2, which means that the general electronic configuration is either ns1 for the first group element or ns2 for the second group element, or ns2 for the second group element. This is the general electronic configuration of s block elements, that is ns1 to 2, either ns1 or ns2, right? Clear? Now let me move to the next block element, that is p block elements. Okay, as we already know, p block elements in which the last electron always enters the p orbital, right? Last elements in which the differentiating electron always enter into the p orbitals of the outermost shell. Therefore, these elements are called as p block elements, right? P block elements. Then, when we move to the general electronic configuration, you can see that the general electronic configuration of these element is ns2 np1 to 6, right? If I am taking group 13 element, right? I will write here, if I am taking a group 13 element, what will be the group 13 element? For example, carbon. The general electronic configuration of this element is okay, group 13 element, I am taking an example of boron here. This will be the electronic configuration, that is 1s2, 2s2, 2p1, which means the general electronic configuration is ns2 np1 for the group 13 elements and ns2 np2 for the group 14 elements, ns2 np3 for the group 15 elements, ns2 np4 for the group 16 elements, and last one ns2 np6 for the group 18 elements or the noble gases, right? This will be the general electronic configuration of p block elements, ns2 np1 to 6. Clear? And also here in the case of p block elements, as I already mentioned that the group from 13 to 18 belongs to the p block, right? And these groups have particular names. If I am taking here for group 13, what will be the first element in the group 13? Anyone? Which element is the first element in the group 13? Boron, right? Boron is the first element in the group 13 element. Therefore, these group 13 elements are also known as boron family. Now, if I am taking group 14 elements, what is the first element over here? In the case of group 14 elements, carbon is the first element over here. Therefore, these groups are also known as carbon family. Similarly, for group 15, the first element over here is nitrogen, so that it is also known as nitrogen family. But there is a particular name for this group known as pnictogens. Pnictogens. The word pnictogen have a meaning of to choke or to suffocate. It restricts the breathing. Therefore, these group elements are known as pnictogens. Then, what about group 16? Our oxygen group family, right? Oxygen group family, it is also known as oxygen family as well as chalcogens. Chalcogens in Greek word means ore forming. Almost all the ore are forming in the form of oxides. Therefore, these name given to the group 16 elements. Then what about group 17? It is a common name, right? Group 17. Anyone? What is the common name for group 17 elements? Including fluorine, chlorine, bromine, iodine. Halogens, right? Halogens. Then the last group, that is group 18. As we already know, these are the inert gases or noble gases. Noble or inert gases. These are the 18, group 13 to 18 elements in the P block element. Is that clear? Now, let me move to the next block, that is D block elements, right? As we already mentioned that in the case of D block elements, the last electron always enters into the D subshell, right? D subshell or D orbitals. Therefore, these elements are known as D block elements. Then, in the periodic table, you can see that from group 3 to 12 constitute the D block elements. In between S block and P block, there will be a group of elements from group 3 to 12. These elements are known as D block elements or transition elements, right? Then, while moving into the electronic configuration of D block elements, we can see that the general electronic configuration of these D block elements is N-1 D 1 to 10, NS 1 to 2, right? N-1 D 1 to 10 to NS 1 to 2. This will be the general electronic configuration of D block elements. Clear? In the case of D block elements, these transition elements can be divided into 4 series based on the periods. It has first transition series in which the last electron enters into the 3D orbital. Therefore, it is also known as 3D series, starting from scandium to zinc, right? Starting from scandium to zinc, this is the first transition series. Similarly, in the case of second transition series, the last electron always enter into the 4D subshell, right? 4D subshell. Therefore, it is also known as 4D series, starting from yttrium to cadmium. Yttrium to cadmium. Then the third series, otherwise known as 5D series, in which last electron always enter into the 5D orbital, right? Starting from half near to Mercury, right? Starting from half near to Mercury, including our lanthanum, right? Including our lanthanum. This is the third transition series elements. Then the last one, that is the fourth transition series, in which last electron always enter into the 6d orbital known as 6d series, starting from Rutherfordium, right? Rutherfordium to Copernicium, including actinium. These are the four transition series in the case of d block elements. Clear? Is the things clear? Okay, now finally, let me move to the last block elements, that is F block elements. As we already know, the last electron always enter into the F subshell, right? It will always enter into the F orbitals or F subshell of the anti-penultimate shell. What do you mean by anti-penultimate shell? If this is our outermost shell, right? If I am taking n here, n minus 1 will be the penultimate shell, right? Just inside it, this is the penultimate shell. Then the n minus 2, again inside to that, this will be the anti-penultimate shell. This is the anti-penultimate shell. If you am taking here, if the element consists of a period of 6, in which the last electron always enter into the 4, n minus 2, 6 minus 2, 4f orbital, right? N minus 2, that is 4f orbitals. 4f orbitals. This is meant by the anti-penultimate shell, right? Now, when we move to the general electronic configuration of the elements, you can see that n minus 2 f1 to 14. This n minus 2 means anti-penultimate shell. Then n minus 1 d 0 to 1. That is the penultimate shell. Then the last one ns2. This will be the general electronic configuration of F block elements. Clear? While observing the periodic table, you can see that these F block elements, right? These F block elements are classified into two series, right? What are they? F block elements are classified into two series. What are they? Lanthanoids and actinoids, right? In the case of lanthanoids, it starts from cerium to lutetium. These are the 14 elements after lanthanum, right? 14 elements after lanthanum. Similarly, there will be another series known as actinoid series, starting from thorium to plutonium. Thorium to plutonium after actinoid, right? After actinium element, this will be the actinoid series, right? These are the classification of all the elements into 4 different blocks. I hope it is clear for everyone. Is that clear now? Now, let me move to the next topic, that is, in order to find out the position of an element in a particular element in a periodic table. Finding the position of a particular element in a periodic table. As we already know that, in order to find out the position of an element, we have to find first block, right? In which block it belongs to. Then we have to find out the group number of the particular element, right? Then finally, we move to the period number. There are some rules or the points you have to be noted to find out their particular block as well as group as well as period. Let us see one by one. In order to find out the block, group and period, first you have to write the period electronic configuration, right? If any element having the atomic number is given, you have to first find out the electronic configuration of that particular element, right? Then you have to find out in which subshell it in which subshell the last electron is enters. That will be the block of that particular element, right? That will be the particular block of that particular element. For example, if the last electron enters into the S subshell, it will be the S block element, right? Now, let me move to the group number. Finding the group number of the particular element. There will be 3 different classifications, right? If the element is in the S block group, S block element, the group number will be the same as that of the number of electrons in the outer S orbital. For example, if I am taking here, this is the element, right? One of the element having the electronic configuration of 1s2, 2s1. Here you can see that last electron is entered into the S subshell. So this is an S block element. Then what will be the particular group of this particular element? Same as that of the number of electrons in the S subshell, right? Which means 1 will be the group of this particular element, right? Now, if we are considering a P block element, then what will be the group number? Just add 12 to the number of electrons present in the P subshell. The number of electrons present in the P subshell plus 12 will be the group number of the P block element, right? Then, for D block elements, it will be the total number of electrons present in N-1D subshell and NS subshell. The total number of electrons present in the N-1D subshell as well as NS subshell will be the group number of D block elements, right? Then, what will be the group number of F block element? Is there any trick? F block element, what will be the group number? Is there any trick? Okay, while looking into the periodic table, you can see that all the F block elements are belong to the group 3. Just remember that. Group 3 elements. All the F block elements are belong to the group 3. These are the points to note out to find out the group of a particular element. Now let me find out the period of a particular element. So that while writing the electronic configuration, you can see that the highest value of principal quantum number n. The highest value of principal quantum number n will be the period number of that particular element, right? If I am saying here the same example, right? 1s2, 2s1. What will be the period number of this particular element? I hope everyone familiar with the quantum numbers, right? As you already mentioned or you studied in your previous chapter, structure of atom. Okay, these are the quantum numbers. You can see here the largest quantum number is here, n is equal to 2, which means this particular element belongs to the second period, right? Clear? Now let us see some examples for this particular practice. If you are giving an element here having atomic number of Z is equal to 20, what will be the electronic configuration? What will be the electronic configuration? I will write here. One is 2, right? 1s2, 2s2, 2p6. How many electrons are there, right? 6 plus 2 plus 2, 10. Then 3s2, 12. Then in which orbital then next electron will go? 3d or 4s? Again recall from your chapter structure of atom. You have studied about the Aufbau principle, right? Aufbau principle. (3s2, 3p6), right? According to the Aufbau principle, you can say that the electron will enter into the 4s orbital before 3d, right? 4s orbital before 3d. So that you can say that here the 2 electrons will enter into the 4s orbital. Then you can predict which block it belongs to. In which block it belongs to? This particular element. Just look into the last electron, in which subshell it is entering. Yes, right? Because the last two electron will enter into the S subshell, therefore this is an S block element, right? S block element. Then, if we are getting the S block element, how we can find out the group number of that particular element? How we can find out the group number of that particular element? Same as that of the electrons present in the S orbital, right? Here you can see that the 4s2, which means 2 electrons present in the ns orbital or the 4s orbital. So we can say that this belongs to the group 2. Group 2, right? Then what will be the period number here? What will be the period number here? The highest number of quantum number, right? 1, 2, 3, 4, which means 4 is the period here. So we predict the position of this particular element as this is an S block element contain group 2 having the 4th period, right? You can see that in the period table, S block element, right? Second group here in the 4th period, 1, 2, 3, 4. Which is the element here? Second group, 4th period. This is the calcium, right? Having the atomic number of 20. So we can predict that this is the element calcium. Right? Clear? Similarly, the next example having Z is equal to 34. Please write down the electronic configuration with me. Right? This will be the electronic configuration of this particular element. Z is equal to 34. You can see that the last electron always enter into here in the p block, right? P subshell. Therefore, this is a p block element. Then, what will be the group number here? If you are considering a p block element, what will be the group number? Just adding 12 with the number of electrons present in the p orbital, right? Here it is 4 plus 12, it will be 16, right? It belongs to the group 16. Then what will be the period over here? The maximum number of n value. The highest value of n value, that is 4, right? It belongs to the 4th period. While looking into the period table, you can see that p block elements, right? Here, group 16. Group 16, right? Here, group 16. In which period? 1, 2, 3, 4. The point you have to note that the last electron, the period number is 3 here. Okay, 3 here. So you can say that here it belongs to group number 16 having the period 3 with the symbol of Se, that is selenium. Right? Okay, again, this is the same, right? It belongs to the 4th period, which means this is the 4th period, that is the selenium element, right? Now, this one, Z is equal to 24. Write down the chemical form, write down the electronic configuration, right? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4, right? We will try to write the electronic configuration like this, but this is a specific case, right? I have already mentioned that in the case of chromium, having the electronic configuration of 4s1 3d5 in order to get the half-filled d orbital, right? This is a chromium element having the atomic number of 24, right? So while writing the electronic configuration, you will get 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 and 3d5, which means the last electron is enter into the d subshell known as d block element. Then which will be the group number of this particular element? Group number of this particular element. If you are considering the d block element, you can say that the total number of n-1 d orbital plus ns electrons, right? 5 plus 1, 6. It belongs to the group 6. Then what will be the period? Same over here, it is 4, right? Maximum number of quantum number, that is period number 4, which means that group number 6, right? Group number 6. Group number 6 with the period 4, 1, 2, 3, 4. Period 4 having the atomic number of 24. This element is chromium, right? Clear? Clear? Now let us practice some questions based on these particular topics. Here is the first question for you. Which of the following configurations corresponds to an inert gas? Which of the following configurations corresponds to an inert gas? Which one will be the answer? 2, right? Inert gas belongs to group 18, right? So we have to just find out the group number. It is group 8. While calculating here, you can see that this is the element having the group number of 18. 6 plus 12, right? That is 18. Which means option B will be the correct answer here. Clear? Now let me move to the next question. The elements of a vertical column have. The elements of a vertical column have. Or group. The elements of a vertical column always have the same number of valency electrons, right? Same number of valency electrons. Which means option 3 will be the correct answer here. Now here is the next question. Which of the following is an element present in the D block but not a transition element? Present in the D block but not a transition element. Options are given here: cadmium, copper, calcium and chromium. Yes, option A, cadmium is the correct answer here. Because of the complete D10 electronic configuration, all the elements like zinc, cadmium and mercury, it belongs to D block but it does not consider as a transition element. This is not a transition element because of this completely filled electronic configuration, right? Now, here is the next question. The element with electronic arrangement AR 3d2 4s2 belongs to which block? As you can see here, in the case of the last electron is enter into the D subshell. Therefore, this element is known as a D block element. Option 3 will be the correct answer here. Here is the next question. Lanthanum belongs to which block? Lanthanum belongs to which block? Which group? Whether it is F block, P block, D block or F block. D block, right? In the periodic table, you can see that there will be an element lanthanum in the D block. After lanthanum only, the lanthanides comes in the 4 of elements, right? Or the F block elements. All the lanthanides are the F block elements, but the lanthanum or actinium are the D block elements, right? This is a D block element. Clear? Here is the last question. The electronic configuration of an element X is given as 1s2, 2s2, 2p6, 3s2 and 3p3. What is the atomic number of the element which is just below the element X in the periodic table? First, we are just calculating the atomic number of this particular element. 6 plus 2, 8 plus 10 plus 2, 12 plus 3, 15, right? This is the 15th element. You have to find out the next element in the below this element, right? 15. So you are just adding 18 to that. You will get an answer of 33. The 15th element is nitrogen and the next element, 33 element is arsenic, right? The 15th element is phosphorus. The next element is arsenic. Which means option A will be the correct answer here. Clear? Okay, this is all from my side for today. I hope it was clear for everyone. If you have any doubt, you can ask now. So far, we have completed the first part of this particular section, that is the classification of elements, starting from the Dobereiner's triads to Mendeleev periodic table, then the Moseley periodic table. We have completed the nomenclature as well as classification of elements. The next session onwards, we will study about the properties of these particular elements in the periodic table, right? Anyway, do like, share this particular session to your friends and subscribe our channel. Stay connected with us for more lectures. Thank you all of you. Bye bye. Take care. Good night.